second Estero Boulevard Lighting Project Stakeholder Meeting. Similar to the first meeting, this is recorded. We're all stakeholders because you and we have a vested interest in the outcome of this project. A lot of public streetlight designs use common criteria, but every single streetlight design is unique because of its geometry and its land use and its traffic. And especially in this case, its environmental concerns. We've compiled what we think are all the criteria and considerations that we should be thinking about as we approach the lighting design. And you are attending today to hear what we've gathered in terms of design criteria for Estero Boulevard lighting and the basis for all that criteria. And it's my hope that you'll hear the presentation today and you'll say, wow, they finally really figured out what's important for us at Fort Myers Beach. And if that's the case, I want you to say so, and then we'll be done and we can proceed. But maybe you'll say, okay, you guys got A, B, and C, but you didn't say anything about X, Y, and Z. And in that case, we want you to tell us at the end what's important to you. Maybe we missed something, or maybe
these people on Zoom.
Maybe we touched on it, or maybe you'd like to share a different context or nuance that maybe we didn't capture. So, okay, here's the hard part. We have about an hour's worth of information to share with you. We want to take all the comments and questions at the end. So please, during the presentation, either take notes and tell us at the end, or you can write in the chat window at the time that you have the question, and we'll compile those to begin the discussion with questions and comments at the end of the hour. So I hope you have your beverage of choice. I have two. And let's get going. To start, we have a 6-minute video that I'm going to share that introduces again the project, introduces ourselves, and outlines how the presentations are going to go this afternoon. And Katie, I'll start the share now and let me know if the sound or video is not good. Otherwise, I'm going to assume that it's perfect.
All right.
I'm going to share that screen, optimize for a video clip. Share that screen, share now. And do you see the black video screen, Katie?
Yes.
Okay, here we go.
The town of Fort Myers Beach has begun a project to develop plans and specifications for construction of a street lighting system for Estero Boulevard. The Estero Boulevard lighting project limits are from Bowditch Point at the north end, all the way down to the south end of the island at the intersection of Estrelita Drive, about 6 miles overall. If you find Estero Boulevard on Lee County's GIS website called Find My Road, it shows who maintains the road. Roads shown in yellow are maintained by the town of Fort Myers Beach. That includes Estero Boulevard north of the intersection of San Carlos Boulevard. And you can see that all the side streets are also yellow, being maintained by the town. Roads shown in red are state maintained. For example, this portion of San Carlos Boulevard that heads toward the Matanzas Pass Bridge is FDOT maintained. Roads in blue are Lee County roads. The entire length of Estero Boulevard south of San Carlos Boulevard is owned and maintained by Lee County. If you've driven down Estero Boulevard lately, well, first of all, you've seen a lot of construction. That construction is a major Estero Boulevard improvement project in progress that includes road widening, sidewalks, center turn lanes, drainage, and utility improvements. You can read more about this project at the website refreshfmbeach.com. Driving down Estero Boulevard, you also see that there's existing lighting almost everywhere along the entire length of the island, and you might be wondering why there's a need at all for an Estero Boulevard lighting project. The most important reasons we need to look at lighting now are to meet design criteria for safety of the improved Estero Boulevard, to update obsolete technology, to mitigate accidents, and to meet the needs of nesting sea turtles and their hatchlings. The existing lighting layout was not developed to light the new, wider Estero Boulevard, so the layout needs to be reviewed and updated to meet lighting criteria for the new road. The existing lighting system is high-pressure sodium lights, a technology which is becoming obsolete and expensive being replaced by more energy-efficient LED lights. A very important reason for looking at lighting is the history of nighttime accidents along Estero Boulevard, including bicycle crashes and pedestrian fatalities. While we can't always control people's behaviors, lighting can do a lot to improve safety and reduce the occurrence of nighttime accidents. So far, the goals of improving safety and energy efficiency are common, ordinary goals of any street lighting project. But Estero Island has a twist. It is, of course, the sea turtles. Right now, most of the Estero Boulevard lights are turned off, completely off, because they could distract nesting activities and the hatchlings' nighttime journey toward the surf. Every inch of the Gulf Side beach could be an attractive spot for a sea turtle nest, and therefore no part of Estero Boulevard is exempt from turtle considerations for its lighting design. Lights that are turned off, as they are now, are doing nothing for safety or visibility, and there are ways we can provide lighting during the nesting season. The design priority of the Estero Boulevard lighting project is to find a solution that provides lighting for safety during the entire year, including turtle and non-turtle seasons. Being turtle safe and people safe are not mutually exclusive. So to summarize, the reasons we're looking at lighting now are to address design safety criteria for the improved Estero Boulevard, to update the technology to more energy efficient lights, to mitigate occurrences of nighttime crashes, and to provide all this while accommodating the important needs of the nesting sea turtles and their hatchlings. 4 of us are presenting different aspects of the design considerations for you today. First, Rick Kaufman will talk in general about why we light and how lighting can affect safety, security, and community value. Rick will also touch on the topic of light color and what current research says about the effect of exposure to different colors of artificial light on human health. Ed Kramer will talk about the accident reports and statistics along Estero Boulevard and how attention to lighting in specific areas can improve safety. Then Rick will come back and describe the transportation engineering safety design and lighting requirements of Lee County and the town of Fort Myers Beach. Joe Hancock will take a few minutes to talk about how lighting affects sea turtles and the requirements set out by the Fish and Wildlife Conservation Commission so that any lighting proposed will have the least possible effect on turtle activities. Joe is a scuba diver, so if you see any underwater photos of sea turtles in his presentation, he took them himself. We all have profiles on LinkedIn if you want to know more about our past projects with lighting in turtle-sensitive areas and the lighting industry in general. It's all up there. You've met Katie Kaufman, who's helping us keep everything and everybody organized. I'm Suzanne Lansford, and I'm the engineer of record for this project. This concludes my part of today's presentation. Thank you all so much for being here.
Okay, I've stopped the share. So I said in that video that it concluded my part of the presentation, but I'm pretty much going to be talking all day. Okay, Rick Kaufman is up next to talk about the reasons we provide lighting at all. I want you to know that he's outlining for us a much longer presentation that we give for the University of Wisconsin's Effective Roadway Lighting Engineering Continuing Education course. He's made it very focused and concise for the town of Fort Myers Beach, and it's compressed content. So again, if you have questions, please write them down and we'll address them at the end. So now I'll turn it over to Rick. Go ahead, Rick.
All right, and Rick, just so you know, your mic is muted right now.
Okay, now I'm unmuted.
Yeah.
Now, can you see my screen okay?
Yes.
Okay, thank you. Okay, why do we install roadway lighting? RP8 is the American national standard for roadway lighting. And all of the other agencies in the US and North America go to RP8 in order to get their lighting levels. That includes federal highway, AASHTO, TAC, etc. So the four main purposes listed in RPA for roadway lighting is the first one, their reduction in nighttime accidents and the associated injuries and economic loss. Also, it's a major aid to police protection and providing a personal sense of security, facilitates traffic flow, and promotes business during the nighttime hours. Also allows for use of public facilities during the nighttime hours. So what I want to share this afternoon is that how, when we're designing for safety, we can also include security, commercial interest, and community pride in our designs and how these work together for the good of all. Okay, on a global scale, we look at the pie chart here. Road traffic accidents is the number one cause of injuries on a global scale. And then if we focus on the US, these boxes that have background in black with the white text, those are motor vehicle traffic crashes. As you can see, for several age groups along the top here, that it's the number one or number two cause of death in the US, especially in younger people. And it makes the top 10 in all categories. So reducing traffic deaths, at night is a big thing. Okay, here I have a chart. At the bottom scale here, these are in 3-hour increments. So if we start here with this column, from 3 to 6 p.m., 6 to 9, these are when the accidents occur. And over half of them occur in the dark. We look at the ratio of nighttime to daytime motor vehicle crashes based on miles traveled. The nighttime crash rate is more than 3 times that of the daytime crash rate. And if we look at the most current data that's been published by Federal Highway, then we can say that total crashes in these recent years are like 6.7 million, and the fatal crashes are, in excess of 33,000 per year. So these are some attention getters, and they show us the need for safety lighting during the nighttime hours. Now, if we look at the economic impact, and this is in billions of dollars of all types of crashes, it's approaching about 800, almost $1 trillion a year. And that's what the burden is on our society every year now. This data is from 2010, hasn't been updated, but I would imagine in 2020, it was a lot more than $1 trillion. Another issue we've got to deal with, particularly at night, is aging drivers. And we've already passed the 2020 mark here. Federal Highway Administration estimates that people 65 and older will be a roughly 20% of the driving age population. So we need to make accommodations for the older drivers. And one of those reasons is that as the eyes age, vision is clouded. We see here on the left, these are views at different age groups. And as you can see, it gets dimmer and dimmer as we age. On the right here, this is the lens from a human eye at various ages. The upper left-hand corner is at 6 months. The lower right-hand corner is at 91 years of age. So we can see as we age, our lenses will yellow and eventually turn brown. At this point, probably somewhere in these years, in these age groups, people will have cataract surgery, and that'll correct most of that. Now, the number one problem at night is headlight glare and how to mitigate it. And that is one of the main reasons for roadway lighting at night. So we see that glare kind of reduces our visibility distance, or the distance we can see, increases our reaction times to objects that may have entered the roadway, and it increases our recovery time. So we're going to look a little more at that. This chart shows by age group the glare recovery time. In a young person, it's about a second. In an older person, it can be up to 3 seconds. So how far does a car travel in 3 seconds? Well, it depends on the velocity of the car, the speed. So if we look at this is a chart that's used in legal cases. And what they've done here is they said, okay, this is the speed in miles per hour. This is the amount of braking distance, the reaction time, and the total stopping distance. And we can see at 35 miles per hour, this gold band, that at that speed, cars can safely stop within the visibility of their headlights. On low beam, the visibility of a headlight is about 150 feet, and on high beam, it's about 350. Problem is, when you go to high beams, you're definitely blinding the oncoming traffic. And then we see the safe stopping distance for a truck is greater than the 130 feet. So 35 miles per hour would begin to outdrive the visibility of our headlights. The red zone, we're definitely, at these speeds, we're definitely outdriving the visibility of the headlights. And at these lower speeds, then we're in safer conditions. So countermeasures for reducing these effects of headlight glare, and I kind of roughly highlighted this, that fixed lighting is the most effective. And we'll look at some more data here. This study was put out by the Federal Highway Administration, and they're ranking roadway safety improvements with the highest benefit cost ratio. As you can see, the number one rank here is illumination or lighting, and the payback is very high compared to some of the other safety improvements available. This study was a result of taking some surveys from states, as well as doing literature reviews on reported accident reductions. And when you consider the location and whether it's nighttime, daytime, or both, you can see there are substantial reductions in accidents. In most cases on the state surveys, most of them are 40% or higher. And in reported, it's again the same story. And we see as much as a 64% reduction here. So that is significant. Now, the next question beyond safety is, can improved public lighting improve security? There's two theories. First one is deterrence, where we've got better visibility, improved surveillance that increases deterrence, decreases nighttime crime. The second theory is the investment theory, where potential perpetrators see investment in lighting is a community investment. The community's improving, they're more conscious. There's better cohesiveness, we're looking out for one another. There's more of an informal social control, neighborhood watch groups, and so on. So what we realize is not only decreased nighttime crime, but also a decrease in daytime crime. Now, this is further highlighted in a document published by the U.S. Department of Justice. And it's improving street lighting to reduce crime in residential areas. And they did this in conjunction with a Professor Ken Pease. He is a criminologist, licensed psychologist. lives in the UK, but he is kind of a leading worldwide expert on crime reduction. So one of their conclusions is that improving lighting can reduce not only daytime crime, but as well as nighttime crime. If you want more information on this, you can visit this website and download a copy of the guide, as well as other relevant information. Now, the third thing is the economic development. This study was done by the Lighting Research Center in Troy, New York, Rensselaer. And what they realized was that with improved lighting, nighttime pedestrian traffic increased by 70%. When that happens, there's an increase in economic activity, but there's also a caution here: don't overdo it. They're recommending lighting levels of 10 to 30 lux. That's about 1 to 3 foot candles. And this next slide shows a study done in Albany in New York City by LRC. And what they found is this is the 10 to 20 lux zone here. And this study shows that at 50 lux, it starts points of diminishing returns. That means you add more light, but people don't feel any more secure. So this is not a bad zone to live in. And this also is within the Lee County lighting guidelines. So we see that community value of improved lighting is not only better visibility, increased nighttime activity. We tend to get better neighbors. We get to know each other, and we're all working during the day, and then at night we can get together in neighborhoods and kind of watch out for each other. And we see less crime and higher property values as a result of this. And then responsible lighting. I always like to emphasize this, that we want to address community needs for safety and security. We also want to conserve resources, minimize energy consumption while we're meeting these other needs. And then we want it to be environmentally friendly. We got to be sensitive to glare, light trespass, and sky glow. And when we are, this further builds and enhances our community. So here's how safety, security, commercial interest, and community pride can work together for a good lighting program. And at this point, I'll turn it over to Ed.
All right, thank you so much, Rick.
So Ed's up next to talk about accident history and how attention to lighting in specific areas can improve safety. We do understand that Estero Boulevard's new sidewalks, the bike lanes, the additional crosswalks that you've seen constructed are part of a body of safety improvements that through our project is going to include lighting. So let's turn it over to Ed to start his screen share. Go ahead, Ed, I see it. Awesome.
Just to let you know, Ed, your mic is still muted.
Oh, great. Can everybody hear me now?
Yes, thank you.
Okay, my name is Ed Kramer. I have had the pleasure of meeting several of the folks that are joining us here today. That's probably because I live fairly close, just up the road a piece in Sarasota. My task here is to talk about accident data and effective lighting, dusk to nighttime lighting. All the data that I'm talking about here today has been gained from the Fort Myers Beach and the Lee County websites. Some of this might be repetitive to some, but it also helps identify the key issues and elements that we will be addressing. The town currently has a resident population of about 7,100 people. The town hosts approximately 1.8 million visitors per year. that economically is very attractive for the residents of the town and for the town itself. A large number are tourists, many of whom are seniors, and this does generate significant pedestrian and bicycle activity. Needless to say, much of this activity occurs after dark. According to the Florida Green Book roadway standards and documentation in Lee County, existing lighting along Estero Boulevard has been identified as less than current standards recommend. Again, our task from RFP 21-3, Lighting Consultants, was to develop a set of plans and specifications that meet current best design practices of the Florida Fish and Wildlife Commission and the Florida Department of Transportation. The town of Fort Myers Beach crash data, as we saw earlier, vehicle, pedestrian, and bicycle traffic safety, is a major concern. 5-year data on the 6-mile stretch of Estero Boulevard shows that there were a total of 663 total crashes. 5-year average shows that nearly 25% of all those crashes occurred during the nighttime. But the accident rate with pedestrians was clearly 50%, almost 50%. And where we look at this kind of data, 12 during the daytime, 11 at night, virtually half of the accidents with pedestrians is at night. Let's take a look at some of the existing conditions here on Estero Boulevard. This is taken from the camera at Newton Park North. At 4 p.m., you can see it's, bright sun. It's really good, and we can see clearly. As we've seen earlier, the older we get, the more our eyesight ability actually diminishes. It may have not been clear, totally clear, but all of these pictures are supposedly taken at the same time during the day. And the eyesight visibility is actually reduced just because of age, as Rick had explained a little bit earlier. But we look at this and we see that at 8:30 p.m., visibility over here at Park North is really great in the crosswalk. But as we see later on at 10 p.m., there are really very, very dark spots between the light poles. Many of the existing streetlights have light sources and reflectors that create hotspots of light intensity that causes visual confusion, squinting, and adverse effects. If we come to the town hall camera, we can see how increased nighttime glare produced by oncoming vehicle headlights where streetlights do not exist. 4 p.m., of course, is very clear. At 8:30, where the dusk is starting to set in, glare is starting to become more visible. And by 10 o'clock, it becomes very disabling. At this moment here, I'd like to just sort of define glare as I see it and as other people see it. The first example is headlights. So if you're driving and someone comes at you with a car or a truck at 4 p.m. and their headlights are on and it's daytime, no rain, and it's not hazy, it really doesn't bother you very much because the ambient light, the light all around you is pretty high and your eye adjusts to that. But those headlights coming at you at night causes a lot of glare that creates, visibility problems. Here we have an example at 8:30. We're starting to get glare at dusk, and certainly at 10 p.m., the glare from the headlights has certainly become disabling. Another way of looking at glare is to consider a 4-foot fluorescent tube and a 150-watt light bulb. Not that you can really buy a 150-watt light bulb easily today, but hopefully many of us will remember it. I bring those two examples up because they both give off or generate the same amount of light. But when you look at a 4-foot fluorescent tube, and then you look at a 150 watt light bulb, a 150 watt light bulb, causes temporary blindness. And it certainly increases the recovery time as we get older and how your eye adjusts to seeing again. The little definitions of glare, I hope it helps. If we continue to go south, and we're now at Newton Park South, we see that the unlit areas from 4 p.m. to 8:30 to 10, the areas that have poorly lit or no light are certainly hazardous to both motorists, pedestrians, and cyclists if they're out at this time. It is certainly obvious the minimum light levels drop significantly below the minimum recommended levels of 1-foot candle and 7-foot candles. Again, our task was to develop a set of plans and specifications that meet Fish and Wildlife and Florida Department of Transportation requirements. Thank you.
All right, thank you so much, Ed.
You, Ed. Okay, Rick is up again next to talk about actual lighting design criteria from Lee County. So I'll turn it over to Rick to start his screen share. Go ahead, Rick. And unmute thyself.
Sorry. This is where we stopped a few minutes ago. Then we want to continue on. This slide gives us kind of a range of color temperatures that Ed talked about. As you can see down here, this left column kind of gives you a little description of what we're looking at. And we start with the warmer, down around 1500 Kelvin. Kelvin is the measure of color temperature. It's an absolute scale. And it's not pronounced degrees Kelvin, it's just Kelvin. So we can see the warmer colors down here, the candle, a sunrise. High noon is around 5,000. And then as we get the northern sky, at midday could be as high as 8 or 8,500 Kelvin. So as we see the more yellow at the bottom, more blue at the top. And on the right side, it gives you some artificial light sources that would fall at about that. Now, your current high pressure sodium is down here around 2,000, 2,200 Kelvin in that range. And the incandescent bulb that Ed described is a little above that, and so on. Now, a lot of studies have shown, and let's look at the 4,000 Kelvin for a second. You can see it's still at what we call, it's in the neutral white range, but it's in the yellow end of or the warmer end of the neutral white range. We're going to talk more about this because that seems to be the magic number. This is a chromaticity diagram, and this is how we measure color temperature. And if you look at point T here where my cursor is, there's about a half a dozen ways to get to that shade of green. And if you take J and H and mix them together, you get T. If you take F and G and mix them, you get T. So color temperature can be confusing because it's a mixture of colors, whereas a spectral power distribution that Joe's going to talk a little bit about is a better metric because it gives you the power intensity at each wavelength. It's more cumbersome to work with and design with, but the IES and other groups are working on ways to do that, to include spectral information when we do the lighting designs. But for now, we've got CCT, and it's approximate, but it's better than nothing. So that's where we are there. Now, this was a study done in San Jose several years ago. The key thing here is that we look across the bottom, it gives us different light sources. Includes high pressure sodium that Estero Boulevard has today. and also looks at 4,000 Kelvin LED, 3,500 Kelvin, as well as 5,000 Kelvin LED. And the star here highlights where we're looking at 5 colors. How well can you detect and see these 5 colors and at what distances? The further distance that we can see something, the safer we're going to be. We're going to avoid more crashes that way, the further we can detect things. So if you have pedestrians wearing these colors, 4,000 Kelvin is the best overall to detect pedestrians and bicyclists wearing these different colors. So this is generally our color temperature of choice to work with.
Hey, Rick,
Yes,
quick question. Can we ask questions throughout, or would you prefer we wait till the end? It's just kind of easier throughout because we may have a question on a specific slide or data you're showing us.
sure. If you look down here in the lower right-hand corner of my stuff, if you'll just jot down slide 28, then we could come back to it. But Suzanne has asked us to hold the questions till the end.
Okay, I didn't realize that. I missed the first part because I have a couple questions, but I'll wait till the end. Thank you.
Thank you. Okay, now this is Lee County, came from Lee County website. And in there, they have color coded the road classifications for the roads in Lee County. And this is Estero Boulevard, goes along here. You can see it's color coded kind of a mid-tone blue. And if you look over here in the mid-tone blue, they consider that an arterial. And so that road class gives us input into the, as to what the road classification is and what the lighting levels should be. This next chart came from the FDOT Lee County lighting levels. So I got this off their website, and this is the road classification. We're looking at our minor arterial. And really for this, there's not a lot of difference between some major arterial, minor arterial values based on the general land use. Intermediate was how Estero is classified. So it's a minor arterial intermediate use, which means there are some commercial establishments along it as well as some residential. So this bar across the middle here, horizontal bar, tells us where we're going to be looking for our lighting levels, uniformity ratios, and so on. The pavement classification is an R3. It is a new blacktop, but it is a blacktop. And that tells us the reflectance characteristics of the pavement. And based on that column, we come down and we see that for Estero Boulevard, that 1 foot candle illuminance is recommended. And that if we're doing luminance method over here, 0.9 candelas per square meter. Now, illuminance is the light that is strikes the surface of the pavement. Luminance is the light that's reflected from the pavement that the driver or pedestrian would see. 0.9 is a good level because it has been in tests have shown that internal lighting levels in vehicles these days is about 1 candela per square meter. So the eye is adapted to that level of lighting inside the vehicle. So having the same light level on the outside of the vehicle is a good thing because the eye is already adapted to that. The eye adapts to change in lighting levels. It adapts to increases in lighting levels very quickly. It adapts to decreases in lighting levels very slowly. Go totally dark adapted could take as much as 15 to 20 minutes. So we want to light the outside to about the same level as the inside or better. Also, we have to consider the surround lighting, where if there are commercial establishments in the area and their parking lots are lighted to higher levels, then we need to think about bumping our roadway lighting levels up to kind of match that. so that we don't have bright areas and dark areas. Now, these next few slides, we're going to talk about health effects of roadway lighting. This was presented at the IS annual Street Area Lighting Conference last year. And because of the pandemic, it was done online instead of live. Currently this year, they're planning to do it live for now. So we'll just look at the test here. Now, Virginia Tech Transportation Institute is probably the main go-to for Federal Highway Administration on roadway lighting research. It's located in Blacksburg, Virginia. Federal Highway funded the installation through Virginia DOT, what's known as the Smart Road. At Virginia Tech, the Smart Road can produce any type of outdoor environment. And so there's a lot of outdoor lighting, roadway lighting testing done at the Smart Road at Virginia Tech. And that's where this testing was taking place. So what they did is they looked at melatonin suppression. And melatonin levels are, melatonin, a little bit of background, is hormone released in the body during periods of darkness. And it's like a chemical dark. It tells the body it's time to rest and repair. And a lot of doctors believe that melatonin is important to fight cancer and other diseases. But so we use melatonin as the metric as to the effects of lighting on health. So the thing here is we want to look at is that 4,000 Kelvin, we're going to compare that to other things. The melatonin levels were fairly constant, and that the difference between 4,000 Kelvin LED and no light is the same. Okay. The other thing is, what about consumer electronic devices using these after dark? So they have a full brightness mode, they have a dark mode. So part of this study looked at that, and these are some values that were measured, for example, using an iPad at night or a Kindle, an e-reader, or a smartphone, watching television, and so on, using a computer with a monitor at night. What effect does that have? And we've learned from the Lighting Research Center, they've done a lot on this, that the suppression of melatonin is caused by dosage, its intensity and duration. You have to know those two numbers to determine your dosage, to determine the effects on health. So looking at these factors, we've got another chart here. At full brightness with its other devices, you can see watching TV at night is about 20 times higher dosage of blue light than street lighting. And that's the main point here, is that if you watch TV after dark, you're messing with your circadian rhythm and other factors. It could affect your health. So the point is that either it's in full brightness mode or dark mode, roadway lighting is the least offensive of any light source at night that you might experience inside or outside the home. And the street lighting levels are not high enough to suppress melatonin production. Now, this study will be published the end of June. That's next month. Through the Federal Highway Administration, you'll be able to go to their website and download it. So conclusions. The researchers came back and said, look, we don't see any need to modify any current practice in roadway lighting because there's just not enough effective roadway lighting to affect it. And that was the bottom line. So that concludes mine, and I will stop and turn it over to Joe.
Okay,
Hey, can I just make a recommendation or a request if possible? Is there any way, just because I'm taking a lot of notes here, and I'd prefer if possible that maybe we could stop at the end of each speaker and see if we have any questions about that particular pitch.
we just have one more speaker and then we'll come back for questions.
Okay.
Thank you.
Okay, thank you, Susan. Is my presentation showing properly?
Not yet.
Not yet.
Not yet. I got the mic. I'm sorry, folks. I forgot to share. I was so busy making sure I wasn't muted.
It's okay.
Joe's
Yeah.
going to talk about lighting and color effects and sea turtle activities and what that means for streetlight design. Go
How
ahead.
are we now?
Perfect.
Yeah.
Great. All right. My name is Joe Hancock. As mentioned before, I was in Florida Power and Light for 37 years, the last 9 of which I worked in street lighting. I'd like to talk a little bit about turtles. And there we go. Sorry. Disorientations. First, I'd just like to make sure everybody understands. We talk about hatchlings all the time, but actually the female adults also are subject to disorientation. And while they have fewer of them, the impact is generally greater. As Rick was saying, there's multiple ways to looking at visible light. When you get down to it scientifically and you want to talk about the actual light itself, the energy, you need to talk about wavelength. When we talk about color, as Rick mentioned, we're pulling different energy levels together, and it can be misleading when we're talking about the effects on humans and species. So we're going to talk about the actual wavelength of the light. And the wavelengths start at violet at the lowest level, work their way up to red. Turtles have very similar range of vision to humans. However, studies show that they tend to react less to the higher wavelengths, to the orange to red, what we're going to call amber in this presentation. When hatchlings come out, if they can come up, get a quick orientation, they will move straight to the water. Otherwise, they will either tend to go in a spiral pattern trying to find where they're going to go, or sometimes just completely stop. In order to get their orientation, typically what they're looking at or trying to absorb in is that the dune should be the darker region and the ocean should be brighter. The ocean will be brighter due to natural phosphorescence, the whiteness of the surf, and the reflectiveness of the water, which includes lights coming from stars, planets, moon, reflections off of clouds. Light coming from the direction of the dune is where the problem is. That will disorient the turtles, have them think that the water is that direction and cause what's called a disorientation. And it's very, very important to note it's both the light color and the intensity of the light that they trigger off of. So FWC has criteria for dealing with streetlights. And the simplest one is, if you can see it standing on the beach, you need to deal with it. So the first 3 options are pretty mild. You change the style of the lens. We would change out a drop lens to a flat lens. Rename the fixture, reduce the wattage. These are very easy things you can go out and take care of. The rest get a little bit harder. Find another pole to relocate the fixture to, shield the light source, or replace the fixture with an amber LED. The last resort is you either disconnect it for turtle season or completely remove the light. Once again, the point source of the light must not be visible regardless of the wavelength or the source. So back in 2014, I worked with several manufacturers to try to get an approved LED light in the amber range, a turtle-friendly light. Internally, we met with many manufacturers. We whittled down to 3 manufacturers, tested those in the Florida Power and Light Lab, and came out with a single fixture that we felt could not only meet the needs of amber lighting, but would meet Florida Power and Light standards and be a cost-effective solution. So in August of 2014, I worked with the FWC team, and we went to Turtle Beach and Siesta Key, as well as Bradenton Beach to Anna Marie, and we performed field testing with new hatchlings with, as I learned that day, light naive turtles. Each section of beach was split into the north and the south. We did 2 sets of tests at each beach for a total of 4 tests. On one particular night, the north half would be dark, the south half would be amber LED. On the next testing on that beach, we would swap the dark section and the LED section. The hatchlings were released one at a time in a test arena. The pattern and the direction were recorded, and the results were statistically analyzed. Coming out of that statistical analyzation was there were no difference between the hatchlings released under the amber light versus the ones in the dark areas across all 4 test areas. Based on this testing, FWC approved amber lighting at 590 nanometers or above. Since that time, it's been lowered to 516 nanometers and above. And that moves a bit towards the not quite as red. And you can see in the pictures on the left here that it is a very deep red with a little bit of orange coming out of it. So a little bit more about the amber lighting. It is red-orange in color. The picture on my left is my blue pickup truck. There is a sign on the dash. There is a Gator license plate on the front. Very difficult to see color or detail in these pictures. Amber currently is the last resort before turning off lighting in an area. They still require shielding. The point source of the light must be blocked from the dune. This will cause some dark and bright spots in the lighting. There is also very little color rendition. And this is of great importance to first responders. Being able to tell the difference between blood, oil, gasoline, water, antifreeze cannot be done under this color of lighting. Signs can be difficult to read. Clothing can be very difficult to discern. For more information, FWC has 2 great resources, one on sea turtle lighting guidelines and the other on coastal construction. By the way, that is my favorite picture there. That was in Indonesia. Thank you very much.
Oh, I love that. Okay, thank you, Joe. Okay, that's the end of our slide presentations. I just want to take one more minute. I want to add that we are aware that the town of Fort Myers Beach has a lighting ordinance of its own, and it very clearly states, among other parameters, that no new outdoor lights shall be visible from the beach, and that includes street lights. So we're aware of that. I want to just take 1 minute to talk about what we're thinking about as we explore the lighting design. We're thinking about, okay, what does a positive result for this lighting design look like? For example, would it be a positive result if we improved how safe people feel when they're out at night? Would it be a positive result if we were able to reduce the turtle false crawls and disorientation events? Absolutely. Would it be a positive result if we applied known criteria for better visibility to reduce the likelihood of nighttime crashes and pedestrian fatalities? I hope so. And probably just as important, what would be an unacceptable result? We think about, okay, if we do something and it reduces how safe people feel at night, is that unacceptable? If we increase the likelihood of turtle distractions, or if we increase the likelihood of nighttime crashes or fatalities, would that be acceptable or unacceptable? Or most likely, what combination of positive and less positive outcomes is right for our design? just for thought. We have an opportunity here with this project to serve the public safety during the entire year and an opportunity to preserve the environment during the entire year. On purpose today, we've avoided the discussion of specific design options. We've already gone through our entire hour, but we've been working on it. We've been collecting information toward a design. We have not yet made any decisions about lighting systems or products. It's our job as specialized engineering consultants together with you to make the best recommendations for the town. That's why we're all here. And then once the plans are prepared, any contractor who bids will be able to submit any product that meets the specification. Last month we went out there, we performed an audit of the existing lights on Estero Boulevard and the side streets so that we're confident that we know the existing conditions. We drove 100 miles on the island over 2 days, collecting that information. So we're starting with a pretty good record. We've gathered information from 9 or 10 different manufacturers who make turtle safe light products. We've looked at shielding. Why do we look at shielding? Because sometimes a light in the right place for the roadway still needs a shield to block its view from the beach. And also there are residences near Estero Boulevard where people would not appreciate seeing a light source from their home. So when we do the design, we have to look at the placement and shielding of every light in the final design. And we're developing some preliminary layouts for a town-owned system. We're considering available turtle-safe products, and we're investigating the possibility of dual source amber and non-amber LEDs in the same luminaire. It's possible that could be switched by a network controller by season. We've been talking with FPL's people who decide which equipment goes in their lighting program about FWC approved turtle lights, and even the possibility of maybe adding a dual source product to the FPL program. And of course, the feasibility of any of these is going to depend a lot on costs. So we're developing cost estimates for when we're ready to do comparisons. And that activity needs to happen in the next few weeks in order for us to be complete with the project by the end of September. We need to be expedient. So I'm done. I'm done. You've all been so great. Thank you for your patience. We know you had questions. And so at this time, I'd like to go ahead and open it up to the questions.
I have a few if no one else does. Let me know when you're ready.
We're ready, Leah.
Cool. So first off, you guys showed a lot of great data, pretty common sense data, right? As far as aging eyes and things of that nature. The data regarding, and you had about 6 slides, so I won't make you go to each one of them, about, car crashes, accidents, nighttime accidents, so on and so forth. You showed a slide showing global deaths caused by injuries. I think it was slide number 4. And road traffic accidents are 24% of that. So just to compare apples to apples, is this highway, do you have any kind of further analysis, just kind of looking at the data with regard to, is this a I-95 type situation, or is this a 2-lane highway in a 35-mile-per-hour zone situation?
Can you speak to that, Rick, or shall I? I think you're still muted. Mute.
Okay, am I unmuted?
Yes.
Thank you.
Yeah, the database is not that detailed as to tell you the type of roadway. In some databases, you do get that, and most you do not.
Okay, because you showed about
that-
6 slides on it. So we understand that, crashes are detrimental, but I was just curious to see, how big of an issue is it? Again, on a 7-mile barrier island, 2 lanes, 35-mile speed limit, quite frankly, 25 in half the area. So I was just curious if that was as severe in a market like this versus, a turnpike or an I-95. So I assume all that data is compiled, right?
It's all composite, right? Now, if you recall Ed's presentation, he homed in on Estero Boulevard, and the chart he had there at the end of his, which
What
showed,
slide was that? Do you have that slide number?
I don't, but Ed does.
Maybe we can
Yeah.
switch. There we go.
Yeah, let me stop sharing, and Ed, if you'll pull yours up again.
That's all right. You
Let's
can
see.
send it to me. You can send it to me. I don't want to waste time. That's fine. If you don't mind, if you could just share it with me, that'll be awesome. Oh, you're going to share your screen.
Okay,
So right here.
Can
Okay,
you
what are we
see- can
looking
you-
at here?
can you see this now?
I
Is this
can.
visible?
Yes, I can.
Okay, this is the data from Lee County information.
Okay.
So five-year stretch of data starting from 2013 through 2017
Okay.
shows daytime and nighttime accidents, and lighting was reported or not reported. Most of the time it's not reported. But
Okay.
they broke it down to motorized vehicles, bicycles, and pedestrians. So if I look at all accidents and I total it all up, then it's about 25% of the total number of crashes or accidents happen at nighttime.
Yeah.
If I look at just pedestrian accidents, 50% of the pedestrian accidents happen at nighttime.
Well, where do you see that? I only see one fatality. Which is not good. Don't get me wrong.
Well, this is all accidents. This is not just fatalities.
Oh, I thought you said deaths.
No, I said accidents. I'm sorry if I said deaths. I don't mean that.
Oh, okay.
This is
All right.
just accidents. This is just accidents.
Okay. All right, cool. That's good.
And-
Now, do you have any
So-
other data? Because it seems to be,
Right.
well, it seems to be at least it dropped from 17 to 15. All right, cool. I love data. That's good stuff. All right, here's a couple other questions for you. So, so you guys, let me just kind of get my notes here on track. So you guys, I think, Ed, you showed a slide depicting glare and said that glare was defined by headlights and glare at dusk. So what data did you analyze to determine streetlight glare? You guys showed data from San Jose, New York, the UK, and some other places, but I'm curious as to, because again, I think I shared with you guys, the American Medical Association, the US Department of Energy, and how, quite frankly, when they talk about glare specifically for streetlights, it's kind of completely opposite in what some of these other cities and the data that you're using. So I'm just curious as far as, like, help me understand a little bit more about how you determine glare from streetlights and what data sources you used other than perhaps some data out of San Jose or New York or the UK that is more medical, scientific, so we can get a better idea of what streetlight glare, what the risks actually are. And why didn't you include AMA data or the US Department of Energy, which are two pretty good sources?
Well, if I can answer that, am I still unmuted here, Suzanne?
Yeah, you're good.
Okay, so the data that I presented is the data that I was able to get from the Fort Myers Beach traffic cameras. We're located in different places. The north showed crosswalks and lighting at a crosswalk, fortunately. The one at the town hall showed no crosswalks, but and no street lighting right there in that specific area. So the glare that we're getting at the town hall, if you look at this at night, you can see is strictly caused by the traffic, the cars coming in both directions. That's where the glare is coming from.
So then my question, so my question would be then, do you have any data, scientific data, not video cameras, but scientific data showing the glare risks at different levels on the human eye?
That would be information that Rick would have. My information was to just demonstrate the conditions that exist along Estero Boulevard.
Okay.
And I used your cameras just to show the conditions that exist, not to quantify it or to define it based on age of the drivers or age of the bicycle riders or pedestrians. I just wanted to show the existing conditions at various times during the day. And these are conditions that we're trying to address and find the right answer to these solutions.
Yeah. So real quick, Ed, one more question, because you said on one of your other slides that Fort Myers Beach is, and this is what you said, less than what the current standard recommends. So I'm curious, maybe I missed it, but what is the current standard that you referenced and what location is that as far as like who's making this recommendation? And again, I'm trying to look at comparing a 2-lane, 7-mile barrier island because when you look at this data, I mean, it's kind of misrepresenting if you're not really comparing apples to apples. So I'm curious as to, if we're less than the current standard, what is the current standard, and who determined what that is?
Actually,
Hey, Ed, this is Rick.
Yeah, go back to Rick.
If you'll
Rick had
stop,
the,
we'll go back to mine. I'll show you where that data came from.
Okay, that was I think your presentation, Ed. Though I have your name written by it, but maybe not.
Yes, yes.
Thanks, guys, for answering these questions. I just have a few more.
Toward the end of mine, we looked at what are the standards for Lee County. And these are the lighting levels. Now, on glare, this last column is called veiling luminous ratio. That's a metric for disability glare.
Okay.
Okay. And what is required by Lee County is 0.3 to 1 ratio. And that's
Is that
the max.
everywhere? Is that like a 41 in front of, a huge plaza and a Burger King and a McDonald's on the corner versus, again, I'm going to go back to a 2-lane Barrier Island, 25, 35 mile an hour. So again, I'm just trying to understand this data, if it's generic that it should go across the board, or is a Barrier Island looked at a little bit differently?
Okay. This does not cover parking lots.
Parking lots? No, I didn't say parking lots. I said a road like 41, that if you're driving down 41 and you have, plazas, you have Burger Kings, you have lights everywhere. So of course you're going to need brighter street lights because there's so much light everywhere else. So I was just curious if this would apply to the Barrier Island street.
okay, lad, the values would not apply. For 41, you would go up. Most likely that would be classified as arterial and commercial. And if you look at the top line, you will see that there are higher lighting levels for that. For a residential street, if you look at local and residential, you'll see there's lower lighting levels. These are the Florida DOT recommended lighting levels based on the usage of a roadway. It also takes into consideration the type of pavement or lack thereof, and whether you're looking at the light coming down or reflected off. So you take all the different aspects of the road and you find the appropriate cross section for what you're looking for.
Okay, cool. And now if you guys could just three more slides, if I may. So slide 28, I just want to look at slide 28 real quick. I had a question during that time. You guys told me to wait. Yeah, right there. So again, help me understand this. This is San Jose. So why did you choose a San Jose study? And it says that a San Jose study, it depicts what lighting level should be. So it should be for what? What data was this based on? And again, is this a comparison that we can compare our island and our street and our environment compared to wherever this is done in San Jose? And why did you choose the San Jose study? Other than it shows that 4,000 K is not harmful, contrary to the American Medical Association. But why did you choose this study?
Okay. First off, it just happened that the study was performed in San Jose. San Jose commissioned this, the city of San Jose commissioned the study. That's why it was performed there. There's nothing unique to San Jose about it other than that's where it happened. Their lighting levels are the same as the other chart I showed you, the one for Lee County. They work off the same lighting levels as everybody else in the U.S. This chart was developed from the AASHTO Lighting Design Guide, published by the American Association of State Transportation and Highway Officials.
Well, that's right. Yeah, I get that. I was just asking about the San Jose study. All right.
Okay.
And then two other things, slide 32 and 33, where it talks about health, which quite frankly, you notice I'm not talking anything about turtles. I do think, the turtles deserve the right lighting, but my main concern is my health, my family's health, my grandmother's health when they're driving down the street. So let's take a look at this a little more. The melatonin suppression, and I know you had presbyopia on here and all that. So remind me again where this health data came from. What clinical research did this data come from?
This is a new study. It was commissioned by the Federal Highway Administration,
Of course.
and it was conducted at Virginia Tech Transportation Institute in Blacksburg, Virginia. And they just finished the study a few months ago. They're doing the data reduction in the final report,
Mhm.
and the final study will be published at the end of June.
Yeah, because as you know, you probably, if you know anything about data, you can make data say whatever you want. But my biggest concern is I can't understand
Well,
why
like
this
the AMA,
data.
right?
Well, no, well, not only the AMA, it's the United States Department of Energy. I mean, it's a
Okay.
very long, and they got numerous studies within that final report. So, and they all say the same thing. In fact, there's numerous data that says the same thing with regard to the 4000K. And it does cause damage according to other data points. And I'm just concerned why all the data, I mean, clearly, and I get it, you're pitching us on, it's going to be 4000K. I'm pretty sure that, and that's really what it was before we even had you guys. That was what the first consultant did, because again, it is the least expensive. So I'm just curious as to why you're not showing any data at all, because this is recorded and this is on record, you know, why, and if people do have an issue and do get at risk, you're going to be liable. If people do have an issue due to extreme glare from the street lights that you may put in. So I'm just curious in why you're not showing any risk data at all that could be associated with the 4000K lighting. And the data also that I've seen doesn't show that no light, they actually show low light is better than too bright light, quite frankly. So I just see too much data, and I haven't looked at the data for quite some time because I haven't really been involved. I'm hoping you guys are going to do the right thing, but I'm just curious as to why, and I'm concerned actually, why you're not showing us any risk data for glare, and you have no data really on what the detrimental side effects of glare could be on the human eye. Did you do any research on that at all?
Well, I did show you some slides on the effects of glare, and that's why I did, because we got to be cognizant that headlight
Show
glare
me those slides
exists.
again. Was it New York? I know you had Albany in there. Again, it's just, you also have to look at, and what some of the data shows is it varies based on, like I said, if you're on 41 and you have all kind of storefronts along 41, it's different. It reacts differently on the eye than a barrier island like we live on. So I'm sure you're aware of that, being lighting specialists. It's not apples to apples. So all the data you're showing us is just one big picture data. What I'd like to see is what are the risks of that on this particular street?
Okay.
And I don't see that. I mean, look at all the cars, even in the photo. We never have traffic like that. It's single file. So I'm just curious and just kind of, you know, pushing a little bit as far as what, and what do you say here? Fixed lighting appears to be an effective countermeasurement. Appears. I mean, come on. Where did this come from? It appears to be an effective countermeasurement to the negative effects of headlamp glare. And you have to also keep in mind that we do not have headlight glare like that. We have one car coming at us at a time. So I just, and when it says appears, is this scientific data? Where did you get this source?
Well, in the upper right-hand corner here is the source of this study.
So Douglas Mace out of Pennsylvania. You're going to use
Doug
his
Mace,
data.
yeah.
You're going to use his data instead of the AMA or the U.S. Department of Defense. Help me understand that.
Let's back up. The Department of Energy.
Or Department of Energy. Thank you for that correction.
Yeah, I work with the Department of Energy on LED roadway lighting.
Okay, great.
Yeah, I'm a member of their executive committee for the Solid State Street Lighting Consortium.
Okay, so what do
And
you
I've
think about
worked
the
with
data?
them since 2009 on LED roadway lighting. So I'm familiar with their publications. As a matter of fact, I've contributed to them. If you Google their website, you'll see a number of DOE workshops that I conducted on LED roadway lighting.
Well, then, I
And,
mean, if you read their
nothing
conclusion
in
of the
those, deals with specifics on glare. And like I say, that's
Oh, it
something we
does.
analyze when we do the final lighting design and make the recommendation on what to do on Estero. We'll give you the numbers for Estero. Right
Well,
now,
I'm
we're
not really
talking
sure if
in
we're talking
general
about the
terms.
same study, but it specifically talks about this, Calvin. It specifically talks about glare. I mean, it's just more than the Department of Energy and the AMA. There's numerous reputable, not a guy from Pennsylvania that no one's ever heard from. I'm just curious. It just seems like you're leading us down this path, and quite frankly, I don't buy it. I'm concerned that you don't have any risk data in here that's comes from a reputable source that's scientific. That doesn't like start with fixed lighting appears to be an effective countermeasurement. I mean, come on. Appears?
Leah, if I could interrupt for just a moment, this is Joe.
Sure.
First, data does not give typically does not give exact results. You look at the data and you see what it shows you, and that's why he used the soft lighting appears. But on the bigger picture, I'd like to make sure you understand, we are not locked in on any particular solution. Right now, we are still in the data. We're still in the data gathering mode. There is 4,000, there is 3,000, there's 560, there's 590. There are a lot of solutions out there. We have not chosen one. Also, you are very correct. Low lighting is much better than too much lighting. In many LED installations, we've had experience with that. Overlighting can cause a lot of issues. If we're going to go one way or the other, we will lean towards lower lighting. But in the interest of fairness, I think now we've spent 20 minutes on your questions. I'd like to ask that we see if there's anybody else with questions.
I've got a couple questions here, actually. First, maybe an observation. So to better understand the slide that Rick had shown on the glare. So is the glare coming from the cars that were shown from town hall cameras? Was that because there was an absence of, or is that because of the high pressure sodium was unable to negate the vehicle glare? Is that the suggestion, and that overhead lighting does in fact negate vehicle glare?
Yeah, Steve, I believe that was in one of Ed's presentations with the pictures down, but that's what it is. When the human eye, as you're going from light to dark, that causes some conflict, where bringing in some vertical lighting will help reduce the amount of that headlight glare.
My question is there was high pressure sodium lighting there is overhead. So you're suggesting you have to increase that then? Or was it possible that
It's not. Typically increasing it won't do it. Typically you add in intermediate lights rather than, you have another thing, valence glare as you're going in and out from the overhead. So typically what you're trying to do is widen the light rather than strengthen the light. Typically, we'll have to do a lighting layout on these roads, but that's a general answer.
Okay. Also a question really on the, I guess I'm a little bit concerned about the Virginia Tech study. It won't be published. It seems like you're putting a lot of faith in that study. I mean, it hasn't been published yet, I guess, nor peer reviewed. So, I mean, those are just concerns I have to really get behind that and move forward on that medical, that medical condition regarding human health. The other question I had was on slide 27 on Rick. On slide 27, you had talked about the makeup of a 4,000 K light. Are you suggesting that with the different wavelengths, are you suggesting that you can produce a 4,000 K light using only the the green spectrum, the 500, the higher wavelengths?
No, if you look at point E here, you could pick points, opposite points on, it's called the triaxial stimulus here, but you've got a coordinate system along this axis, this is another axis in this, or you can use the Cartesian color coordinates. But at this point E, if you want to get to E, there's a number of ways to get there using color mixing.
Is that,
Just but to add to that, you can only mix colors that manufacturers make chips in.
True.
including,
Not all colors are available. That's right. For
including-
example,
Mhm.
you know, we were looking at one project at 3,500 Kelvin, and there are not a lot of products on the market
Mhm.
at 3,500 Kelvin. So,
Okay, well, it seems like my understanding, maybe I was looking at that intersection at T and it was, I misunderstood the,
now, the point making on this chart is what it's showing here is that you've got these pairs,
Mhm.
and if you mix this color with that color, you get this color.
Okay, but you always have,
Another way is to mix this color with this color, you get the same color. Or
But
this
you-
color and this color, you get the same color. So there's 3 ways shown on this chart to get to that shade of green.
so I guess, can you do it by eliminating the short wavelength blue light? I guess that's maybe my real question.
Well, the problem is if you eliminate the blue totally, then you cut out your color rendering.
So your
And
CRI,
your color rendering index drops down to, for a monochromatic source like amber,
Mhm.
the amber LEDs that are available are virtually monochromatic,
Correct.
which means you're going to get no color discernment. Things will look black, white, shades of gray.
Correct.
But you saw the picture of Joe's blue truck and it looked black.
Sure.
So for emergency personnel, trying to discern, okay, is that motor fuel all over the road or is it blood? There's no way to tell.
I find that to be a completely irrelevant argument, to be honest with you, because if you've ever seen the scene lighting on a first responder's vehicle, it's usually loaded with halogen or LED light as it is, which makes
It
really
could be.
the overhead
If they
light
have,
irrelevant. Correct? I mean,
yes, sir, if they have auxiliary lighting, you're correct, and then they can use that.
Mhm.
It's like fire trucks are equipped with scene lights
They sure
So,
are.
for that
Steve,
reason.
Yeah.
This is directly from first responders, yes. Once they set up the scene, they have plenty of light. When you're getting out of the vehicles and walking up to the car, when you're stepping out of their vehicle and looking down, what they're stepping into, that wet spot, under 595, 60, 612, they can't tell what it is until they set up their lighting. That's just feedback we've gotten over time from first responders. Yes, once they get set up, they have light, but not until they set it up and when they step out their car. If a police officer is going down the road and they see somebody running away from them as they go up into different colored lights, whether to say that that guy is wearing a yellow jacket or a gray jacket or a blue jacket, the different discernment, that is one of the pushes we had from Miami-Dade Metropolitan Police was color rendition of a fleeing suspect. And it was very important to them.
I mean, there's roads that are unlit in this county. I mean, would you suggest that those need to be lit then? I mean,
Yeah. Again, we're not suggesting anything, just
need to be lit in this entire world in order to support fluid recognition at emergency scenes and or crime prevention.
no,
I guess
sir.
point.
I'm not saying anything has to be done anyway. What we're trying to do is get all the available information out
Mhm.
and get
Well,
the opinions from the different stakeholders. Again, we are not taking a position. We're just gathering data.
Okay, well, I guess the positioning of some of these slides, I think, are meant to direct a little bit. So I guess
yes, I agree.
to give a counter argument to those. And then maybe the other thing I had wanted to talk about, Joe, I think you did a great job with the turtle lighting, although the culmination of lighting also, I believe you'll find is a problem. So it's not necessarily just the point source lighting is required to be viewed from the beach, but certainly the culmination of lighting, meaning sky glow, also is a real problem these days. So, you know, you had sort of focused on the point source, and although that obviously is the main problem, I think that the culmination these days with the you know, the proliferating LED lighting has become a real problem with glare and sky glow. Just to add a piece there. I think that might be all for now.
Hey, I just have one more thing to wrap up if there's no other questions, and then
No,
I'll.
actually, Leah, I do have a few questions I'd like to
Oh,
ask.
good. Go for it.
Okay. So with Joe's presentation, I appreciate the information about the turtle lighting and the study that was done on Siesta Key, where you evaluated different options for new hatchling disorientations. And again, this kind of touches on what Steve just mentioned. Was there any consideration for, rather than the point source, sky glow that's associated with either non-red color lights, and how that has an impact on the turtle? While you may be able to shield it from the beach, from visibility from the beach, does the ultimate sky glow that can be created cause any additional problems for disorientation of turtles? I've heard a number of people have commented to me about that.
I can speak to that since I work with the turtles on Fort Myers Beach. We actually have hatchlings that hatch south of the Wyndham that end up heading north towards the sky glow of the Times Square area. So, in any white light that is even on the other side of Estero, and even if it's not white light, if it's high pressure sodium, low pressure sodium, it will draw them. If it's brighter that way than over the Gulf, it will draw the hatchlings in that direction, away from the Gulf. So we have, you know, we're wide open at our beach accesses. We have white 3000 Kelvin LEDs down the beach axes and down the roads from the beach axes now. They have to be turned off. We have, you can see the white, if we have a corridor of light, which is what we need to be safe to travel down Estero Boulevard, we need a consistent corridor of light. That's the most important thing in street lighting, correct? That corridor can attract the hatchlings and disorient the mother sea turtles, because they can see underneath buildings, they can see between buildings, and a corridor of white light, especially 4000 Kelvin. We've already had a disorientation with a 3000 Kelvin, will definitely have everyone going the wrong way. So it's very important. Now, I had a question about, aren't there 3000 Kelvins and maybe 2700 Kelvins now that can perform the way 4000 Kelvins can perform?
You currently have 3000 Kelvin, all the LEDs.
Oh, I know what we have. Yeah, but are there 3000 Kelvin LEDs, newer technology, and 2700 Kelvin LEDs that can perform as a 4000 Kelvin does? We had a FPL representative that said that at one of the council meetings a year ago.
Efficacy, I think, is what you're talking about, right?
All right, so I think what you're talking about is both cost and efficacy. And those deltas have gone away. When I first started working with LED street lighting, 2010, everything was coming out at 6000 K. And the efficacy difference was extreme. The cost difference was extreme. In the last 5 years, it's almost come to parity, and many manufacturers are currently offering 3,000, 4,000, and 5,000 at no difference in cost. So the cost and the efficacy differences, to me, and Rick, I don't think they're significant at this point.
There's about 7% difference. We just did this study in Kansas City, and they're looking at converting the city, and Today we're debating 3 versus 4,000. And we got actual product samples. Suzanne and I did a field study on those samples. The 3,000 draw 7% more energy to get the same light level as the 4,000.
Now, if you go below 3,000, the market's not there. If 2,700, 2,500, 2,200, you do start taking an efficacy hit and a cost hit. But 3 to 4, 4 to 5 in that range, it's not a significant difference.
Yeah,
So
2 or 3 years ago when I did a layout, they're putting in a new interchange by Hartsfield Jackson Airport in Atlanta, and down along the parking corridor in one of the interstates. And the first time I laid it out at 4,000 Kelvin, and when I came back and had to redo it at 3 because the local people wanted 3, I had to use 20% more energy, and that was 3 years ago. And like I say, today it's only 7% more energy.
Right. So since 2016, several large municipalities and cities around the world have changed their 4,000 and higher Kelvin lights down to 3,000, 2,700. People like that better. So if Fort Myers Beach has been telling us, you know, costs maybe shouldn't be the most important thing, and we need to get what we need to get to be safe, and to be safe for the turtles, and to be safe for the people, and to make it easier for people to see. I mean, I personally, sorry, Rob, I have to put my sunglasses on when I'm driving from downtown Fort Myers to Fort Myers, to Fort Myers Beach. And when you go from Winkler Avenue on Summerlin Road and you get to Bass Road, now you have so much light on that crosswalk. I can't see because you're going from dark to super light, white light. I don't know what levels the light are on those light posts because I can't read them like you can around here, but I just have a problem with the white light, and I think a lot of other people will too. You know, we have these 3,000 Kelvin lights on the side street, and people have problems with them being outside their homes. It's hard to see. I know when I ride my bike back from the beach at night, I'm going, well, it's a different situation because we want continuous light now on Estero Boulevard, which we don't have now. But the side streets, you're riding through complete darkness to bright white light that's shining down in a small area to complete darkness again. So that's not safe. And that's not safe on a side street when you're, you know, walking or riding a bike. You can't see someone that's outside that white light, especially if it's cloudy out. I'd like to say something about, to reinforce what Leah was saying. You know, circadian medicine, that's a new thing, and they haven't had time to really explore that. So in August of 2017, Harvard came out with a study that's a medical study about the greater risk of breast cancer in neighborhoods that have higher levels of outdoor light. There's so many more. 2021, a study was published of the positive association between LAN, light at night, and thyroid cancer. I don't think in the age of COVID, you're going to sell anyone on something the AMA is recommending against. I certainly wouldn't want to live under one of those lights. And that's one reason why they are rejected all over the world. So as far as crime, there are so many long-term studies that the lighter the streets are, the safer they are. That's not true. Higher Rice University, higher streetlight density equals a higher level of crime because they're saying that people actually feel comfortable. You actually have more graffiti and vandalism. Yep. Yeah. In France, in January of 2019, the whole country of France said that there's a 2,700 Kelvin limit on their lighting. Light trespass is prohibited, and there's no lighting of waterways. Some more on crime. The 2000 Chicago Alley Project, crime in brightly lit alleyways. There was an increase in crime when they lit the alleyways. 2015, England and Wales, there was no evidence that dimming or turning off lights at night affected crime. So because they wanted to save energy, they turned lights off at night or dimmed the lights at night, and there was no effect on crime. So it just goes on, and I find it contrary to what you're saying. So a couple of slide questions. The Fort Myers Beach slide, I think, is irrelevant because now we have sidewalks on both sides of the street and a very nice street, thanks to Lee County. So I don't know if we had updated statistics, maybe it would be more meaningful to even use a slide like that. I think, Rick, you had a slide. You didn't, the years of the study, I don't even think LEDs existed on one of those slides. So I don't think that slide was relevant. I think that one page you had up there, I forget who it was Rick. It was 2001 was written at the bottom that talked about, I think it talked about having lights, street lights, balancing, whatever that said. 2001 was written down there. So we weren't using LED street lights then. I don't know. I'm concerned about the residents that live along Estero Boulevard for any white light that we use because they are the ones that will be most affected. And I know that there are studies that the most important thing in street lighting is that we have a continuous corridor down the whole road. And the lighting level doesn't matter as much. It just makes people feel more safe. So that's all I have to say.
Rob, did you have something?
Yeah, actually I had a few other things. And you know, Cynthia kind of touched on one thing there. I guess one of the questions I've got is, you know, yes, we should have a continuous lighting, but do we need to have continuous lighting at the same level at every location throughout the corridor? Would the lighting level for the Times Square area necessarily be the same lighting level that you would need in the section from, say, the fire station south to before Santini Plaza? We've got a couple of different, you know, areas that are different characteristics. And then how would you transition from one lighting level to another lighting level? I mean, I would imagine that would be during your design. You would photometric design to have light fixtures that transition, you know, gradually so that people's have that time. And that slide that you showed on adjusting their visibility in that transition. And then the other similar question along that lines would be transitioning from locations that may have turtle friendly, you know, the red color lighting to a white light. What sort of transition would necessarily be appropriate for that? I think there's going to be, right now, I know that the signal project that's being designed at Crescent Street, and then the state project that's being designed at the foot of the bridge at Fifth Ave, and then the town's project at Old San Carlos are all currently designed to utilize the wildlife friendly lighting criteria from FDOT. So how would we, if you went to something that wasn't the same color, how would you transition from a amber to a white light?
Like to take that, and there's a few things mixed in there. So the first is, yes, you do transition. You look at the speed limit, the type of the road, finish of the road, the width of the road, the pedestrian vehicle conflict, and you try to get a zone that is uniform, and you do your lighting from that. Then you do transition between the zones. So each unique section is handled uniquely. So the area between, say, Crescent and Times Square would definitely be handled different than the area south of the window. One other thing is the actual Times Square itself is out of our scope. The town has a plan to handle Town Square on their own, Times Square, and they are dealing with that. So we need to transition in and out of that zone, but it is not within our scope of work. Did that help?
Okay. To some extent, yeah. I mean, I just know that those transition zones are going to exist. And, you know, looking to create some sort of uniformity between all these projects. We've got the state project, which is going to have different color lights, at least what it's currently being contemplated. You know, they'll have sections that may be outside the project corridor that have utilize a white light, whatever Kelvin color is selected. I mean, I think that's kind of can be, you know, obviously can be discussed, and then transition to an amber color light, and where they use the wildlife lighting criteria.
Sticking with white lighting, typically lighting has a primary, a secondary, and a tertiary zone. The illumination is coming out in a cone. You get more directly under, about 1 pole height wide. As you go 2 pole heights wide, the illumination goes down. 3 pole heights, it goes down even still. And what you try and do is set these transitions so you're working with the tail of one overlapping with the start of the other. And that you'll make your transition through the 2 adjacent lights. With the pattern, you have the pattern of the light, the wattage of the light, and the height of the light as the variables that you can use to make these smooth out. Did I miss something, Rick?
No, that's fine. You know, one thing I could add to that is that a lot of states are going to roundabouts in rural areas where there's a high incidence of crashes at intersections. And what I do at roundabouts is I'll start the lighting, you know, maybe several hundred feet ahead of the roundabout. And I'll put the poles and the lights closer together so that as you approach the roundabout, the lighting levels increase, which gives you a visual warning that you're approaching an intersection. So that's kind of transition lighting that we can look at here. It was mentioned that you've got commercial areas that have a lot of bright lighting just off the right of way. So we need to look at those areas and, like you can plan for some transition lighting to elevate the lighting level on the road as you approach that location so that you're not blinded by the bright light as you get there. And then as you leave that area, you need to transition down to a normal lighting level. Cynthia brought up color and a lot of people changing. We had a call with the engineer for the city of Chicago. They're replacing about 330,000 streetlights with LED. And they had a number of stakeholder meetings. They had originally planned to go with 4,000 Kelvin because of the better visibility. But as a result of all the stakeholder meetings, they ended up at 3,000 Kelvin. City of Seattle started with 4,000 or 5,000 Kelvin, and since it's come down to 3,000 Kelvin.
A quick question, just to clarify, when you say city, is this downtown metropolitan areas?
Yes.
You said the city of Chicago and the city of Seattle. So big, bright metropolitan downtown areas, correct?
Correct.
Okay, thanks.
Yeah. But I mean, those were brought up as examples.
Yeah.
I worked with the state of North Carolina on converting their statewide system to LED. They elected to go with 5,000 Kelvin. Their rationale was that this will help keep people awake while they're driving. That was their rationale. So we're going to do them a favor. We're going to keep them awake while they're driving so they don't hit each other.
I heard language like
And
that. It's not.
That's a
Just
lawsuit waiting to happen.
Yeah,
Just to talk
and I tried to whittle them down to 4,000, and they said no, we're going to stick with 5. And
Also, sorry, Rick. One other thing in there is what they're coming from. So typically, the municipalities that I've worked with that were coming from sodium wanted to stay with that warmer light. By the way, some of these were the same municipalities I had worked with 20, 25 years before that didn't like sodium because they were coming off with mercury. But there's also communities that are coming off of metal halide. So Coral Gables, while it's in Miami, is a very residential community. And they had a lot of metal halide in there. They wanted to transition to something that had a similar light pattern. So we started actually with 6,000 in Coral Gables. And they were one of the first places to put lighting in. Since then, Florida Power and Light stopped offering 6,000. I believe they still have quite a lot of 5,000 in there.
So
Again,
they did the streets as well. I went to University of Miami, so I'm very familiar with Coral Gables. So
Yeah.
so did they do the actual side streets where the pedestrians actually live? Because Coral
ma'am.
Gables is very commercialized, so much more than yeah. So they did all the residential streets.
I
The
don't know if
6,000 K.
all of them have been done. They were in the majority metal halide. I'm not talking about Miracle Mile or the commercial section. I'm talking about the interior streets around the golf course, the residential neighborhoods. We started working with them with LED. They were one of the first communities that FPL worked with.
So they have 6,000 K right now in their streetlights.
Like I said, we started with 6,000. I don't know if there's any of that 6,000 left. We
I
transitioned from
see.
that to 5,000.
I got you.
And those are the acorn style fixtures and the what they call the founders poles from the original oldest part of the city of Coral Gables.
So if
Yeah,
Joe
another
doesn't
thing too,
mind-
Joe,
And
is
Rob
down,
and
Excuse
Rick
me.
don't mind if I jump in.
Yes,
I have to
Robin.
get to another meeting. This is Dr. Robin Trindell. I am the administrator for FWC's Marine Terminal Management Program. I just wanted to thank the team for a comprehensive presentation on issues that we also feel are important, because when our staff are asked to review these projects through DOT or other regulatory entities, we're going to balance human safety along with the protection of sea turtles. And you brought up a lot of issues we've heard for many, many years. Color rendition, we've gone all over the place. Some police officers think it's important. Others say eyewitness testimony is not valuable anyway. You know, so we've heard a lot of, we've heard the first responders say, I want to know what I'm stepping in. Others say, no, I'm not stepping in anything until I get my lights set up. So a lot of good issues that you've brought up. You certainly convinced me that color temperature is not a good indicator for our staff to use when looking at risk to marine turtles. We're going to focus on wavelength.
Yeah.
So I do have to say, I was surprised the discussion focused so much on white light, because my understanding of the current standards that the state regulatory and local government are going to use when looking at lights in these locations are you do have to meet the wildlife sensitive requirements for long wavelength. So just a little surprise on my point. On my part, I wasn't at the last meeting, but you know, I mean, that's the way these coastal roadways have gone under DOT standards and the local lighting ordinance. There's been some great successes recently with amber lighting going in along State Road A1A in Fort Lauderdale, Pompano Beach, Treasure Island. They might be good examples for your team to look at. I want to suggest a little bit of caution about dual lighting. You know, our agency is cautiously looking at that, but in very restricted areas. And there's a lot of questions about, you know, now we have these requirements for long wavelength. how do we fit in this dual lighting? And if the long wavelength is safe, why would we create an impression that, you know, it's really not safe? You need to have white light. So just a couple comments. Again, I want to thank everybody because I have to jump off to another meeting. And just hey to Joe. We spent many hours on the beach during that experiment. And, you know, I was out there, I'm an older person, and I was amazed at how well I could see under those lights. I mean, actually seeing for safety under the red was not an issue at all. But we all agreed the color was not something we're going to ask Fort Myers to become a red light district. So we did move to the amber, which is much more, people love it that we hear. So thanks again for a great job. And I'm going to jump off now. Thank you.
Thanks, Robin. Nice to hear from you.
Thanks, Robin.
I was just going to say that I think recently they did a conversion down at Miami Gardens at 3,000 Kelvin, but they've had a lot of complaints that the lighting levels are too low. Now, don't know if that's color related yet, or if it's just they use the wrong luminaire.
And when you say a lot, because that's again contrary to pretty much everything you read about that. And just for the record, too, you know, the Department of Energy data, it does state that every outdoor lighting project is different, and the needs vary accordingly to the project, the client, the users, the activities, the layout of the land. And it also states that they highly recommend that luminaries delivering warmer color light is better. They said definitely lower than 4,000 K and often below 3,000 K. So again, I would just ask you guys to maybe be a little bit more balanced on the data that you show us, because I think, as you could tell by, there were some great discussions on this call, and a lot of people have done their homework and have been looking into this for quite some time. So, you know, just be a little bit more perhaps objective on the data, and maybe show us a little bit more scientific data. There was a lot of, you know, San Jose studies, Albany studies, some guy from Bethlehem, Pennsylvania data, but yet there was no real good, you know, scientific data. I understand people might not like the American Medical Association, but, you know, we're looking at a guy from Bethlehem, Pennsylvania's data. How can we rely on that either? So if you guys could just please, what I would like to see moving forward are the risks. What are the risks? Because I'm sure there's data out there. Just like you said, you're saying there's a few people or many people over in Miami Gardens are concerned about the lowness, the low light of the 3,000 K. We don't know how many that is based on how many population. It could be 3 people complained. But what I would like to see is what kind of scientific data can you show us on the risks involved with lighting at a 3,000 level and a 4,000 level? Can you guys get that for us?
We will work on that.
Okay, great. Thank you.
I have a lot of notes here, and there's a lot of things that I want to respond to that there's just not enough time to address today. This sounds a lot like the roadway lighting guide editing meetings that we have. Very spirited discussion, but people that have important priorities that they want to make sure are accommodated. So what I've done is I've written down the concerns I could capture, and I guess Katie, at the end, you and I can compare notes. And I'll work with Chelsea to see what's the best way to get this communication back to you. But you've asked for more information about risk data for glare. You've asked about consideration of 3,000 and 2,700 Kelvin LEDs, about glare metrics. Steve Johnson, you had questions about glare coming from cars on town hall cameras. I do want to explain a little bit more about those slides, but I'll do it after. Cindy, you mentioned that the uniformity of lighting was so poor on side streets that you didn't feel safe riding through the dark spots.
Yeah.
I think that's important.
That's
point
important.
because one of our scope items is not lighting design detail, but they are asking us for recommendations for side streets, so we're definitely going to include that. You collectively had concerns about, or had cited the 2000 Chicago alley crime study, which is very well known in the lighting industry, as you can imagine, the 2015 England Wales conclusions. And I want to respond to that too separately. There was a concern that the accident statistics on Estero Boulevard may not be relevant in light of the fact that there are now sidewalks and bike lanes. We want to respond to that. Concern definitely, we're all concerned about the residents who would be most affected by the lights along Estero Boulevard because we know there's adjacent residential properties for sure. The need for uniformity, I think it was referred to as continuous lighting. We call that uniformity in roadway speak, and the transitions between if there's color change or brightness change, there's design standards for that. And so we can refer to the way that would happen to make sure that drivers making that transition have time to adapt their vision so that it can keep visibility as much as possible. Let's see, including color transition. If there's any area where there's a transition from turtle friendly to white, we need to respond to that. Robin had a lot of points. She talked about balancing human safety against the protection of sea turtles, and that police officers and first responders have different opinions about what is important. She's convinced that color temperature is not a good metric, where they're going to focus on wavelength. She had a caution about dual lighting. We want to respond to that. And
She talked about the area of wildlife concern, roadway lighting standards for area of wildlife concern, FDOT standards.
yes. I was really glad to hear her say that we all agreed we're not going to ask for red, we're going to ask for amber.
Of course.
For that color. And so just so you know, because we didn't fully respond to your questions today, it doesn't mean we're going to wave them off and call the meeting done and just proceed. We're going to respond. And the how you receive that, I don't know yet, but we'll make that available to you. And we have meetings coming up with Public Safety Committee and also the Marine Resources Task Force coming up next week. So we can continue our conversations then too. We'll have that information ready for you. And we'll probably at that point also be talking about some of the design options so we can get into that. Are there any, what did we skip? Are there any other criteria or questions that we need to also look at?
Maybe one more quick one that I think Rick might be able to answer, and that's just contribution to SkyGlow. Right now we have roughly, I think from the original study, 113, 200 watt high pressure sodium lights. Right now they're all pretty much cut off. I think the majority of them are all cut off luminaires. If there's going to be a continuous, uniform corridor, I believe the original study had called for roughly 70% more luminaires, so going up to almost 200. And at that point, it was 4K white LEDs. Even if those were shielded, I believe there's still mathematically an increase to SkyGlow, correct? Just from going from high pressure sodium to white LEDs.
Let me take one piece of that. HID creates light in a sphere.
Mm-hmm.
You've got a plasma stream and light goes out in every direction. You've got usually have a refractor system, but you still, the old term is a light bomb.
Mm-hmm.
You make an enormous amount of light and it goes everywhere. Mm-hmm. And the light you don't want, you try to shield. The LEDs are much more directional. Now, the question is going to be, what kind of transition do you want at the back of the curb? Some communities want light from curb to keyhole, so that if somebody is walking up to their front door, they have an easy transition. Some communities want at the edge of the pavement, you've got a hard line. We need to get the input from the town on what kind of lighting we want. If you're talking about just lighting the roadway corridor, you can do it with a lot less light with LEDs because you can direct the light to where you want it to be.
Mm-hmm.
Right?
Yeah,
Okay.
and
But there's
it's
still
a
gonna be
good thing to
contribution.
understand what it is your priorities are, because For example, we talked about City of Chicago. Their specification prior to their conversion was they wanted more what they call keyhole lighting for security than they wanted roadway lighting, up and down the street. So the front porch lighting being lighted so they can see their keyhole to get the key in at night was more important to them than the lighting of the street itself. So likewise, if you have priorities in, what you want to see lighted and what you don't, we need to take that into consideration. Now, will there be more sky glow from the wider, what we call broad spectrum lighting? Yes. How much? We will try to minimize that, but there will be some, just because there's more of it.
Right.
And then, depending on what people have brought up, how much blue content is in there. We all know the short wavelength blue light scatters more readily in the atmosphere, especially when there's high humidity. So that, we can take into account as well. And then other people that are, can we get 3,000 Kelvin to perform as well as 4,000 Kelvin? Can. Typically, we bump the light level up a little bit to compensate. And then we get the equal detection that way. So there are workarounds depending on what your concerns are.
But by law, we're required to protect the turtles, correct? I mean,
Correct.
I'm not, yes.
Absolutely correct.
Okay, and then one thing that people always say, one statement people make is they have trouble seeing people coming off the sidewalk into the street. And if you have a street light, on the street light side, on the beach side, those lights some of them are going over the road already. Do you do pole sharing? You have some of those ideas you're gonna use, like a lower light to shine on the sidewalk? If the other light.
I think
Exactly. Now there's a new concept that has been around in the kind of rest of the world scheme. It's new to the US. And we're currently working on that on this revision of RP8. And that's called surround lighting. And what surround lighting does, it lights the equivalent of one vehicle lane on either side of the road, which in a lot of cases would include the sidewalk. But it brings it up to about 70 or 80% of what the light level is on the road. And what that allows is for the detection of people or animals or things approaching the road from the side. So as you're driving along, because of the surround lighting in your peripheral vision, you see something approaching the road, you can take corrective action. You can slow down to discern what it is, or you can stop if necessary. But you have that added visual distance in order to respond.
So for the locals, there's an example of pole sharing over on 41 going over the Imperial River in Bonita. They have the lower lights. We probably wouldn't use exactly something like that because it would have to be shielded, but and I saw them in Chicago too. They have the street lights over the streets and then they have a lower light over the sidewalks. I would just encourage you to use the minimum amount of lighting and be creative. I think that's really why what we were hoping for from you guys.
And I know a few people mentioned, go ahead. Yeah, go ahead. I know a few people mentioned that can we get 4,000 K brightness with 3,000 K? And my question is, do we need that brightness? Again, we're not a 41, we're not a Chicago, we don't have other lights to compete with. So I question that. So I'd like to get a little more info on that. And then my other question is, Robin mentioned Fort Lauderdale, Pompano Beach, and another local places not far that are kind of similar. Pompano Beach and Fort Lauderdale is a little bigger. I know you guys, one of you mentioned Hollywood Beach. Again, no, I've lived in Hollywood Beach and it's similar, but we're still a different, unique island over here. So my question to you is, you've shared a lot of data from a lot of different parts of the country and a lot of different parts of the world, that quite frankly isn't really relevant to our little island. So moving forward, can you provide information that's relevant, to our 7-mile, 2-lane, 35-mile speed limit community in our road? Because you can't really compare us with other parts of the country, or people's complaining about bright lights when we don't really know where that is and what other lights they're competing with. So if you could just share relevant information. And then regarding the risk data, if you could please use a reputable source and make sure it's, if possible, scientific data that's published.
Understood. Thank you.
Thank you.
Thank you.
And I'd love to hear more about what Fort Lauderdale and Pompano is doing in other parts of Florida that are similar to ours instead of other parts of the country.
Okay. Suzanne?
Okay. So noted. You've made a long list. I'm out of water.
Okay.
I would like to end this meeting.
You're going to need a drink.
I am going to need a drink. I do have a drink here, but I've been saving it. This is great for you. You guys have been amazing. I really appreciate you taking all this time and all this care. I know it was more than just this couple of hours that helped in preparation for this. I know it's years of care and concern. We know that. We appreciate that. We're going to do the best thing we can to respond to your concerns. We hear you about the relevant information. We hear you about being creative, and we really hope that you're going to be really happy with our solution in the very end. We look forward to meeting with the committees next week. And if you have other questions that you think of, just send us an email. I'm Suzanne@townlighting.com, Ed@townlighting.com, Tony@townlighting.com, Rick@townlighting.com, and Joe@townlighting.com. So we're easy to find, and don't hesitate to send us questions. And with that, we're going to go ahead and end this Zoom meeting. Thank you so much.
Real quick, are you presenting the same data to the committees this week that you presented to us? The same, I hate to call it a pitch, but the same presentation?
Pitch. No, it'll be a little bit more developed. We're going to talk a little bit more about the designs.
Good. Okey-doke. Thank you.
All right.
Thank you all.
Bye, guys.
Thank you all.
Thank you.